Welcome back to Pop-Up Ologies. In this week's segment, we'll be looking to the skies and asking questions like, where does rain come from? Why are some storms so windy? And how exactly does the weather person know what the forecast should look like? Weather constantly changes from place to place, day to day, and even sometimes minute to minute. Doing our best to understand its ins and outs is important not only for the sake of science, but for the sake of safety too. So let's go ahead and learn a little bit more about meteorology, otherwise known as the study of atmospheric phenomenon, its chemistry and physics, and the weather. The study of meteorology dates back millennia, because weather has always had an important role to play in human history. Being able to guess what the skies might have in store helped them to understand when crops should be planted, when they were likely to have the best weather for travel, or just whether or not it was a good idea to go for a walk that afternoon. Of course, it wasn't until the mid-1800s that the study of weather began to resemble something we would recognize today. Thousands of years ago, people had to rely mostly on what they could observe, often mixed with myth and superstition, in an attempt to understand the often chaotic weather of the world around them. Today, modern instruments make understanding and forecasting the weather a little bit easier. It began with the invention of the thermoscope in 1593, and it is thought, but not certain, that Galileo is the man responsible for its invention, and discovering the specific principle that made its discovery possible in the first place. It's a simple device, built from a vase filled with water in a long tube, sealed at the top with a hollow glass ball. As the temperature outside the ball changes, the pressure inside adjusts to match, and the water at the base rises or falls accordingly. As we continue to advance our understanding of heat, pressure, and moisture, inventions like the hygrometer, which measures water vapor, and thermometer, still widely used today for all sorts of purposes, would follow soon after in the 17th century. Torricelli would then publish his first observations of the newly invented barometer, and just like that, the properties of the atmosphere began to shift from fickle and unpredictable to something that could be measured and described. Today, modern meteorologists can rely on the help of computers, advanced models and simulations, and even satellite imagery to help them out. I wonder what Galileo would think if he could see the weather stations of today. Meteorologists use tools like Doppler radar, weather balloons, and, well, the transmissometer, which measures the degree of attenuation of a light beam at a certain distance as it travels through water or air. Or, put another way, how many particles are in the atmosphere, making it difficult for light to travel. We've sure come a long way. But now let's move on to talk a little bit about how to read the weather without all those fancy instruments. There's a lot we can learn and understand just by looking up. Knowing what kind of clouds are overhead is a good place to start. To begin with, we have high-level clouds, whose name all begin with the Latin prefix cirro, and when attached to another cloud type, simply means high. Composed primarily of ice crystals, they usually look thin, streaky, and wispy. Cirrus clouds are the first in mind, and often indicate a change in weather pattern is on the way, usually a warm front. We also have cirrostratus and cirrocumulus, two other types of clouds that earn their prefix when they occur above 20,000 feet. Our mid-level clouds occur between 6,500 and 20,000 feet, and go by the prefix alto. Depending on the time of year, altitude, and temperature structure of the atmosphere, these clouds could be made of water droplets, ice crystals, or a combination of the two. Altostratus clouds don't usually produce precipitation like rain or snow themselves, but may indicate a transition to wet weather is on the way, so it's best to keep an eye on them. Altocumulus is much the same, except for its unique pattern. Due to its fish scale appearance, these clouds have sparked several colloquial phrases, but this one is my favorite. Mackerel sky, never long wet, never long dry. It might sound silly today, but these sayings helped people pass down weather knowledge through the generations. Next, we have our low-level clouds, which are named for how they're formed. Stratocumulus develop horizontally, and take the form of a low, gray sheet across the sky, thick in some areas and thin in others. These tend to develop either before or after a new front moves in, as moisture in the atmosphere settles and adjusts. Nimbostratus clouds are more of a thick gray blanket, dense and often producing steady rain or snow. When these clouds settle in, you know it might be a day or more before the sun peeks back out. Finally, there's one type of cloud that doesn't quite fit in with these neatly layered sorts. These clouds are a bit more varied, ranging from a perfect summer sky to towering thunderheads. Cumulus clouds are capable of producing some of the wildest weather on Earth. These puffy white cotton balls are a hallmark of cloud gazing on breezy summer days, and usually form when the air is hot and humid. But keep an eye out. As the day reaches its warmest point, see if these cotton balls start to build. When the conditions are just right, cumulus clouds might become towering cumulus, pulling down a rainstorm from the upper atmosphere, or develop into a cumulonimbus storm system. When you think of a towering thunderhead or a massive storm system rolling over the plains, a cumulonimbus cloud is probably what you picture. Stretching upwards of 40,000 feet in the air, showing off sweeping anvil tops, these towering storm systems can produce mesocyclones and tornadoes, shelf clouds, mammatus clouds, hail, spectacular lightning, even stranger phenomena high up above their cloud tops in the form of sprites, also known as transient luminous events. Don't even get me started on hurricanes, droughts, blizzards, firenadoes, pyrocumulus clouds. Weather can get pretty crazy, so trying to learn more about it can seem overwhelming at first. Let's go back to basics. We've got cloud families out of the way, but how do those happen? How does weather happen? Broken down to its bare elements, weather occurs when the sun's energy heats the Earth's atmosphere, causing masses of air and moisture to move. The planet's rotation has something to do with this too, but we'll save that for another ology. When an air mass is warmed, its particles become less dense, and it rises. Cooler, denser air then rushes in to fill the space underneath. This movement of the air is what creates the wind, and when these air masses jostle for position, those are weather fronts moving across the planet. Warm air will rise in the atmosphere until it loses energy and cools. Water droplets are lofted along with the air masses as well, and when those cool, they condense together, forming raindrops. Once these droplets become big enough, they fall as rain. You can check out our hydrology episode to learn a little bit more about how exactly these droplets form. In more powerful storms, where warm updraft is strong enough to keep these droplets lifted for quite a while, along with other particles like dust and debris, they might even fall as hail. In our region of the country, it's important to remain weather aware, whether you're heading out for a hike or just off to school or work. It can get hot in the summer, and awfully cold in the winter too. The Miami River Valley sometimes greets morning commuters with a blanket of thick fog, and it's not out of the question for a stray tornado to wander through southwestern Ohio either. The greater Dayton community was particularly impacted during the May 2019 tornado outbreak, in which 4 tornadoes touched down within our county, ranging from the lowest on the enhanced Fujita scale, EF0, to second from the top, a rare EF4. Out of 1,522 tornadoes occurring in the U.S. in 2019, only 3 achieved the EF4 status, and none were deemed an EF5. With such powerful displays of weather's damaging potential close at hand, it can be easy to grow fearful of what the next storm front may bring, but try not to worry too much. Strong storms form in very particular conditions, which are hard to meet, especially here. For us, we should be more concerned with applying sunscreen and keeping hydrated while out in the summer heat instead. And when the skies do turn dark, make sure to tune into your local meteorologists. Their coverage will help you keep up to date and aware of what is often a rapidly changing situation. Planet Earth sure can throw a lot at us when it comes to weather, and we've barely scratched the surface. Sometimes the weather can be pretty, sometimes it can be dangerous, but the best way to appreciate it is to keep learning more. Be sure to check your weather forecast every day and keep your eyes on the skies. Let your inner meteorologist out to observe the clouds, rain, and wind around you. You never know what you might discover. Thank you for tuning in to another edition of Pop-Up Ologies, and we can't wait to see you next time.